Hello! This video will cover an example problem for the CADapp Frame application. The problem is provided as example 5.3-7 in the PDF file. In Figure 7a, we have a frame problem which features a 100-pound load, beams, one of which is cantilever, and an induced moment from the force. For this problem, we will assume Young's modulus E is equal to 30 million psi, which is a standard value for steel. Using this E value, we can calculate A equals 2.3148 times 10 to the negative 5 feet squared, and I equals 3.4722 times 10 to the negative 6 feet to the fourth, based off of Ku equals 100,000 pounds and K theta equals 15,000 feet squared provided in the example. The problem asks us to calculate the tip displacements. For this tutorial, we will focus on the furthest node from the fixed beam end. To begin, we will launch CADapps. Click Frame. The user interface is similar to that of the Truss app. For questions regarding the Truss app, please refer to its related tutorials and example. First thing we will do is set our axes. Our axes are currently from -10 to 10. We'll resize them to -2 to 6 in both X and Y. This looks a little better. Next, we'll edit the units. Click Options. We'll change the labeling format to numbers. The measurement system will change to imperial. Length unit will be feet. Force unit will be pounds. And the cross-sectional area unit will be feet squared. Click Accept. Now we are ready to input the frame. To begin, we place the nodes and members of the system with the mouse or nodal and member properties table. This is the exact same process as the Truss app. Next, we will give external boundary conditions. Click Boundary Condition under Edit Mode. Click Node 1 and make it fixed. Click Accept. These are all of our external boundary conditions for the problem. Next, we will move on to the internal boundary conditions. By default, each member created is a beam and has a fixed internal boundary at each node. To edit this, left-click on a member. A dialog box will appear which allows the user to apply different internal boundary conditions. Click Accept to accept any changes. However, for our problem, we do not need to change anything. Alternatively, internal boundaries can be edited in the Member Properties table. Next, we will input the load. Click Load under Edit Mode. Click Node 3 and provide a load of 100 pounds in the positive X direction. You will notice that the user will now be able to apply an external moment at a node. For this example, there are no external moments. However, this is how they are applied. Alternatively, external moments can be applied using the nodal properties table. Click Accept.
Whenever you're ready.
Members are in blue, external boundary conditions are in green, loads and moments are in red, and internal boundary conditions are in pink. Next, we will update the cross-sectional areas and Young's modulus for each member. This will be done in the member properties table. These values have been calculated as A equals 2.3148 times 10 to the negative 5 feet squared, and I equals 3.4722 times 10 to the negative 6 feet to the fourth, based off of Ku equals 100,000 pounds and K theta equals 15,000 pounds feet squared provided in the example when E is 30 million psi. Continue until each of the members are ready. Be sure to be careful about units. Next, we will save our work. Click Export. Save to the desktop a file named frameexample.schm. We are now ready to run our problem. Click Run Simulation. A new window will appear with our results. First thing you will notice is the bent member. Since the members are fixed internally, they will bend, and the graphical results represent that. The colors and legend displayed are able to be changed to show axial force, shear force, and bending moment. In the bottom left corner is an animation toolbox. The user is able to play the problem and watch it deflect as the load is applied. The user is able to pause the animation and step through it frame by frame. As with the Truss app, answers are able to be found by mousing over the nodes and members. At node 1, a moment of 480 pound-feet is induced by the 100-pound load. At node 3, we have a displacement of 9.102 inches in X and negative 2.432 inches in Y. These correspond to 0.7585 feet and negative 0.2027 feet in X and Y respectively. These are close but vary slightly from the provided answer in the PDF text. This is because the solution provided uses linear assumptions to solve the problem, whereas the app is calculated using the non-linear solution. By scaling down the problem, e.g. reducing the load to 1 pound as opposed to 100 pounds, the solution matches the linear theory result much more closely. Future versions of the software will feature the ability to run in either non-linear or linear mode. To get a better idea of what is happening in this entire problem, export to a .csv. The CSV has all the information for post-processing and will feature unrounded numbers. For more detailed information regarding the Frame app, please refer to the help documentation provided. I hope this video helped you understand the Frame application. Thank you.